Hey guys, today we're going to learn about the real number system. This should all be a review from back in 7th grade, but I just want to take some time to go over it. We didn't get as much time as we normally would reviewing at the end of the year last year, so I really just want to take that time and focus and remind us what all is going on in the real number system, because later on next week we're actually going to start working with real numbers and having to compare and order them and all of that fun stuff. So really, I just want to go back over this and kind of put this back in your brain before we get started. Okay, now last year you learned what's called a mnemonic device. That's one of those things like, please excuse my dear Aunt Sally, to remember your PEMDAS stuff. Okay, so the one we used with the real number system was never write in red. Okay, so we have the never write in red. And there was a reason that we actually put this in right here on bottom. And that was because this is the order that we use to fill in our real number system. This is the order it goes. Our N is for natural, and that's our smallest, most specific group. So that's why it's at the bottom. So let's go ahead and let's fill in our squares. Now I'm going to not write the whole words yet. I'm just going to write the letters. So N, W, I, R. Never write in red. Okay, so now let's look at what those letters stand for, and then we can fill in as we go along. So the first one we're going to look at is N, and that's our natural and counting numbers. Natural counting numbers are the numbers that you naturally start counting with when you are a baby. Okay, so let's fill that in. They are the numbers that you naturally start counting with when you are a baby. All right. And so think about when you, if you have a little brother or a little sister or even a niece or a nephew, somebody around that's a little kid that they're just starting to learning to count. Okay, they're going to start with 1 and then 2, 3, 4, and so on. They don't skip count. They don't do anything like that. They just start off with the basics. And that's what natural numbers are. They are the numbers that you naturally count with, okay? And so sometimes it's also referred to as counting numbers. So that's the easiest way to remember is natural or counting are the numbers that you naturally count with. And if you can remember that, then it actually covers both words. So we're going to go ahead and fill this in. So we said N is for natural. All right. So this is the box for my natural numbers. And so we said that those are like 1, 2, 3, 4, and so on. Now, I could keep listing, but I don't want to, because we all know that you can sit there and count and count and count and count and count on forever. And as long as you're counting by ones the whole way through, those are always going to be natural numbers, all right? So let's look at our next one. The next one we have is whole numbers. And whole numbers are just natural number that also include one thing. There is just one number in whole numbers that make it special. Otherwise, it's just a natural number. So we have all those natural numbers, 1, 2, 3, 4, 5, 6. But whole numbers have one special thing about them, and that is the number 0. 0 is the only thing special about these. And so right here, you need to either circle it, underline it, whatever you need to do. But that natural numbers only are numbers that include 0. Okay, so let's go fill that in up here. So we said that whole numbers are natural numbers that include 0. So I'm going to fill in the word whole. And so we have 0, and I'm going to make that kind of big so it's easy to see because that's the most important number. 1, 2, 3, and 4. And it still goes on. I'll fix my 2 right there. And it still keeps on going on and on and on. I can count as far as I want, but I just stopped it there. So it's all of the natural numbers that you've been using plus the number 0. Okay? The next group gets quite a bit bigger. So let's look at him. The next one we have is integers. Okay? Integers are positive and negative whole numbers. So we have positive and negative whole numbers. You will also sometimes hear this referred to as whole numbers and their opposites, because think about it. That makes sense. It's a good definition, because if you think about it, what is the opposite of positive 4? Negative 4. What is the opposite of positive 7? Negative 7. So you have all of those whole numbers that you've been using and their opposite. So it also includes the opposite number of it, which is negative, okay? It doesn't matter how big the number. If you pick 783, the opposite is still negative 783, okay? So that's all integers are. We haven't introduced anything but whole numbers yet. We're just now looking at the positive and the negative version, okay? So let's fill that in. We said I is for integers, and those are positive and negative whole numbers. So the way we're going to do that is we're going to have negative 3, negative 2, negative 1, 0, and I'm going to kind of wrap around here. 1, 2, 3, 4, and I'm just going to put dot, 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 because those do continue on. And then, but here's the thing. If it carries on in the positive side, it also is going to have to carry on in the negative side. So not only am I going to put the dot, dot, dot to show it keeps going on the positive, I got to show that on the negative too, because I could still keep counting. I could say negative 4, negative 5, negative 6, negative 7, negative 8, and just keep on going forever and ever and ever, okay? So make sure that you realize that not only does it continue to get bigger on the positive side, it's also continuing to get smaller on the negative side, all right? So let's look at the next one. Now, this one has several pieces because we actually have a couple of vocabulary words that are not quite as common as you would think, okay? So let's look at this one. Rational numbers are fractions, blank decimals, and blank decimals. Now, if you are sneaky, you've looked right here and you already know what goes into those blanks. So if I look at it, they are fractions, terminating, and repeating decimals. Repeating. Having problems spelling that there. Okay, so we have fractions, terminating, and repeating decimals. Terminating decimals are decimals that stop or end, okay? So let's look at this. Again, terminating decimals are decimals that either stop or end. And so think about it. The most common terminating decimals that you see almost every single day is money. Think about it. When you're talking about money, you would say like $3.75. Well, that stops. It ends. It does not say 3.755555555555. Okay? That 5 doesn't keep on going. It stops. So that makes it a terminating decimal. You could also say 0.5, 0.6. All of those numbers stop and they end. Even if it was to go 3 decimal places. So like 0.125. It still stops at that 5, so it's still a terminating decimal. All right, the next one you should be a little bit more familiar with. We have repeating decimals, and repeating decimals are decimals that never stop and they keep on going in a set pattern. And this one is a little bit different because I see every year that my students think that the only kind of repeating decimals there is the 0.333333, and it goes on forever and ever and ever. But notice right here where it says repeating in a set pattern. That changes things, okay? So it's not just one number over and over and over again. It can also be things with a set pattern, okay? So let's go look at this up here. So, rational numbers are fractions. So I'll just put like maybe 3/4 to think about it. Terminating decimals, which we said are a lot like money. So let's just do, I don't know, $10.78. And then we have repeating decimals. Now we talked about the 0.3s. And remember, we can also put a bar on that to show that that 3 is repeating over and over and over again. But it also includes numbers like this. 0.14141414144 ... Because if you look at this closely, it has a pattern. And our definition says decimals that never stop and continue on in a set pattern. 1/4 is my pattern because that same 1/4 repeats over and over and over again. So that makes it a repeating decimal because that same pattern is just repeating over and over and over again. All right. I do want to point out one thing that I see sometimes. These numbers in rational can be negative as well. So any rational number can be positive or negative, okay? So I could have 10.78 or I could have negative 10.78. They would both still be rational, okay? So now I've gotten all of this side over here done, but I still have this blank little box right here. And so I'm going to need to go ahead and fill him in. So if we go down here, that is going to be for irrational numbers. Irrational numbers are decimals that never stop and do not repeat in a set pattern. Notice, they never stop. Well, that's just like right up here when they never stop. But they do not repeat. That's the difference. If you look up here, they never stop, but they repeat in a pattern. The only difference with irrational is even though they never stop, this part right here, that they do not repeat. So you don't have that pattern that you have in an irrational number. And so, for example, the most common one that we see all the time in math has to do with circles, and that is pi. Okay? And now when you think pi, back in 7th grade, you used 3.14. Well, that's because they let you stop early because you were doing it by hand. Do you think they'd really make you multiply a number that's over 1 million digits long in 7th grade by hand? Absolutely not. So they round it to 3.14 and let you multiply with that. When all actuality, pi goes on forever and ever and ever and ever. Okay, so let's come up here. Let's fill in our last little box. And so I can't write that sideways or write that the normal way, so I'm going to actually write him sideways. That this is a rational box. Irrational, yeah, okay. And so we said that the most common one we see is pi. And that is approximately 3.1415 ... And it keeps on going. It's literally at over 1,000,000 digits long. It never ends. We have computer programs running over and over and over again to just keep finding the next digit of pi, okay? So I stopped after 4, but know that it just keeps on and keeps on and keeps on going, okay? Now, even though pi is the most common, it's not the only one, okay? So I can make up one. And again, I'm making up this number. It's not a real number. Well, I guess it is a real number if I make it, but I could be anything. So negative 10.7836954721 period ... Okay, does that number have any kind of pattern? No, not at all. And does it stop? No. So that means that it is irrational because it does not have that pattern and it does not have that pattern and it never ends. All right? So let's try a couple. All right, and again, you do have these in your notes. It's just page 2. So if you've printed these out, great. If you're not, you're following along and you're typing them in slides, that's fine. But it wants us to classify the following numbers in the proper subsets. Please be sure to list all of the subsets. Okay, now the subsets is all of the groups, okay? So remember, I'm going to write this over to the side so I can remember what they are. Never write in red. So that's natural, whole, integer, rational. So let's go ahead and start classifying these. Okay, so this first one we have is negative 564. So if you see this negative right in front of it, that automatically marks out natural and whole. Because the first time that you see negatives are in integers. So that's my first group. It's integers. Now, can I stop at integers? No, because that's the way we write this. It goes here all the way to the top. So it doesn't matter where you start. You still got to keep going to the top. So if I start at natural, then it also fits in whole, integer, rational. Okay, so since this starts at integers, it's integers and rational. So add that rational in there because it says list all of them. So it's not only integers, it's also rational. Okay, so the next one is 0. 0 is that special number, the one thing that makes this group special. Otherwise, it's just the same as natural. Okay, that's whole numbers. So we start off with whole because that's the first place we see 0. And remember what I was talking about. I'm starting at whole, so it also fits inside of integers and rational, okay? I'm not just writing whole. I also have to include integer and rational. All right, so let's look at the next one. This next one is 3,228. I want you to look at your notes, flip back to that last page if you need to, or rewind a little bit if you need to, and think about where would this number fall? Okay, so if I look at these numbers, where is the smallest place it could fit? And if I really think about it, and I really was really bored, I could count to 3,228. Am I going to do that? No, because it would take forever. But could I? Absolutely. So, since I can naturally count there, that means the very first group it falls in is natural. Now, that's at the very bottom of my Never Write in Red. So, not only is it natural, but it's also whole. It's also an integer. And it's also rational. I nearly ran out of room right there. Okay, so that means when you start, just like we said, when you start here at the very bottom with a natural number, that you have to include all the ones above it. So when you have a natural number, it fits in all of the boxes. It fits in natural, whole, integer, rational. All right, let's look at the next two. All right, so the next one I have is 3.79. Okay, now this right here, this decimal at the end is what's going to change it up for me. Okay, that decimal knocks out natural numbers. It knocks out whole numbers. It knocks out integers. So the only box it's going to fit in is the rational. Now, the question is, can you remember what kind of decimal that is? It's a decimal that stops or ends. So it's called terminating. So that is a terminating decimal, and it only fits into rational. All right, so last one. Right here, I have a decimal point. So there's no way it can be natural. There's no way it can be whole. There's no way it can be integers. So it has to be either rational or irrational. And I know it has that ... so that doesn't narrow it down. This one was easy to see it's not irrational because it just stops. But this one keeps on going. The question is, does it have a pattern? And if you look really closely, I see 2.23232323. So that 23 is repeating over and over again. And so if it is a repeating decimal, that makes it rational. Okay, and since it is the one on top, it's my red, it's the very top one, the biggest box. It can't get any bigger. So it is going to just be rational on this one. All right, so that is our lesson for today. You have done the exact same thing that my kiddos have done in class with these notes. You are going to do the same activities as well. So the activities will be posted today. And so your assignment for today is going to be notes and the activities that we're doing in class. So you are going to see on your modules, it's going to be the lesson and notes. And inside there is the notes that I'm writing on right now. And then you will see where it says Real Number System Activities Day 1. So you're doing the Day 1 activities today. And then I will release the Day 2 activities on Monday. So that'll be your Monday assignment. So, again, I won't release those till Monday, so I'll only have posted the 2 things that you have to do today. All right, as always, if you have any questions, just message me through Canvas, and I'll get back to you as quickly as I can. Thanks, guys. Have a great day.